here's a quick tutorial on how to calculate how much of a certain fluid to give for hypernatremias and hyponatremias, or how to correct the sodium. So the first equation that is taught in school is the calculation of the free water deficit or free water excess. And that is to try to tell you how much water would be either needed to correct a hypernatremia or is in excess, needs to somehow be countered in an excess. And that's a little bit hard. It's not actually that useful, but generally that equation, you need to know the sodium that you are at. So the patient sodium, let's say it's 200. And then you need to know what sodium you want to go to for normal. And you don't need to go very low to help a patient, so we could say 150. So if you know those two things, you can calculate that by saying that about 2/3 or 60% of body weight in kilos is made up of water. And then you just need to know the current sodium and the normal sodium. And you subtract 1 to basically get to a fraction, and that will give you a liter of water, either a positive number or a negative number that you need to give the patient. Now, if this is an acute situation, you can give that fluid relatively quickly, but if it is a chronic situation, then you need to give it slowly. You don't want to change the potassium more than 12 milliequivalents per day. It's very hard to control that sometimes. And so this equation actually turned out to be not very helpful because it doesn't really tell you how to do that. It just gives you a number of water. So very smart math people decided to derive another equation from this equation. And that equation is that you can calculate the effect of 1 liter of a specific IV fluid. And that effect, that change in sodium of that 1 liter, will then help you figure out how fast to give that 1 liter. So the change in sodium from that 1 liter of fluid in your patient is calculated by saying the sodium of the fluid minus the sodium of your patient. So we'll do an example one. And then it has the same elements, 0.6 times the kilo body weight plus 1. So you can see that it's really turning the equation a little bit on its head. So let's say my patient will still be 200, and then let's say the sodium in my fluid is that of like normal cell R, which is 140. So that number is going to be negative 60. And this number, let's make our patient a 10 kilo patient, makes my life a lot easier. So that is 6 plus 1 is 7. So that's about 9. So that sodium change from giving a negative 9, right? Negative, positive, negative 9. So if I give 1 liter of Norm-R, that's the sodium of 140, to my 10 kilo patient, it will bring the sodium from 200 down to 191. Well, that's not very good, is it, right? That doesn't change that sodium very much. It's very safe, but it's going to take me a while to give my 20 kilo patient a liter of fluids. So that's not very good for my patient in actuality, because let's see, if I gave a liter of fluids over, if I gave it over, let's say if it did 50 mils an hour, it's still quite a bit. That's still going to take me 20 hours to give that fluid. So that would take quite a while, right? If it's an acute situation, that would be not very helpful. If it was a chronic situation, that might be okay. And that's what I might choose. Well, let's say if I went crazy and decided to give a fluid that had no sodium in it, like D5W, and this number would be negative 200 divided by 7 that would change it quite a bit, right? So that would be 25, negative 25. So that would be a lot better change if this were an acute situation. I could bring this down from 200 to about 275. So that situation would be a lot better. So let's do this if it were a hyponatremia. So let's say my sodium in my patient is 100, and I'm going to give LRS, it's just 135 basically. That difference is going to be 35, and that's a positive 35. And then my 10 kilo patient is still 7, so that's a 5 plus. So I will go from my patient of 100, I'll go to 105 if I give it LRS. And that's a situation where sometimes people will want to give hypertonic saline in different varieties. You certainly don't want one that's like 2,000 milliequivalents of sodium or anything like that. But you may give a half strength, you may give a 3%, and you might get that up a little bit faster. So that's a little bit better calculation to do that. I like that equation much better, and it is in our protocols at the very, very, very bottom.